Today, we are going to discuss an important tool where we can see the frequencies as well as the densities. It is violin plot. But before violin plot, we must understand two important plots: kernel density plot and box plot. Box plot we have already discussed in video 15. But today let us first understand what is kernel density plot. A kernel density plot, as shown in the picture, is a method of visualizing distribution of observations in a data set, which is almost analogous to an histogram. It represents the data using a continuous probability distribution. See, in histogram we see only the frequencies, but in kernel density plot we see the continuous probability density. Kernel density plot, it is relative to histogram. It can produce a less cluttered plot and more interpretable, especially when drawing multiple distributions. But it has the potential to introduce distortions if the underlying distribution is bounded or not smooth. Like a histogram, the quality of representation also depends on the selection of good smoothing parameters. Box plot we have already discussed in earlier videos. It shows the median and then first quartile and third quartile. The thick portion in the box is interquartile, and the extreme observations, which are minimum and maximum, shown as whisker length. But if we join the two plots, kernel density and box plot, we land up to violin. Violin plot, it's a combination of kernel and box plot. See, the median is there as in box plot, quartile 1 and quartile 3 there as in box plot, and then maximum value, minimum value comes. It is there, but the observations which are outliers, they are also shown in the violin plot because it calculates the probability. Now near the median, the probability is very high, the area is very broad, probability area is very high. But as we go to the extreme, up or to the low, the probability goes on decreasing. A violin plot plays a similar role as a box and whisker plot. It shows the distribution of quantitative data across several levels of one or more categorical variables, such that those distributions can be compared. Unlike a box plot, in which all of the plot components correspond to actual data points, the violin plot features a kernel density estimation of the underlying distribution. So it's a combination of box plot and kernel. It is very helpful to see the data where the highest probability is there, where the lowest probability is there. So it shows. We can observe the data, we can visualize the data in a better way than box plot. We are going to use violin plot can be effective and attractive way to show multiple distributions of data at once. But keep it in mind, the sample size influences the estimation procedure, and violins for relatively small samples might look misleading smooth. So data sample size should be okay. I have taken up these paragraphs from pydata.org. Important commands, as we will import seaborn, we can name this as sns. So then simple command sns violin plot data is df. So df will be our array where we have kept our database file. Let us go to Jupyter and start Python. In Jupyter, I can name this file as ViolinPlot, so that when you next time when you see IPINB file, you can easily see this, how these are. First, we will import our normal tkinter and then file dialog box, so that we may open the file, we may select the file, we may open the file, and after reading the file, then if we want the violin plot for one column, we can select that column, or we can draw the violin plots of all the columns at once. So let us import the files first. So I have written the commands: import tkinter as tk, import pandas as pd, import seaborn as sns, import matplotlib.pyplot as plt. The pandas, seaborn, pyplot, they also help us in drawing the charts. But I have imported it so that you may learn the commands, and if it is useful in our software, in our program, we can use it. Import tkinter, import file. From tkinter, import file dialog, and from tkinter, import all functions constants. This star means import all functions, whatever tkinter is there. From tkinter, import ttk. I'm just going to run it because it takes some time to import the files. So it is going to run, and in the meantime, I will start writing the other commands as you have learned in the videos 10, 11, 12, 13, 14, 15. I have written the commands win is equal to tk, win geometry 700 into 500. You can make any size of this window. And then the file dialog box will open a command ask open file name. It will open another window. You can select the file, and then window will be closed. Otherwise, if we don't close the window, it will remain open for even if you close the program, the window will remain open. So then we save our database file, that fp, where is the file name, and fp will be read excel. It's going to read excel only. If the file is csv, then you have to change the command read csv, and df is equal to this. So you can run this. If there is any issue, it will tell you if there is any problem. I have written the commands columns, df columns to list, which we have already learnt in videos 10 to 12, and then it will name the columns. Then it will count the columns and its values, enumerate it with starting with 1. Our index starts with 0, but we will start it with 1. So that is why in our next command we are going to subtract -1 from the number which we are going to put it. M is the length of the columns, num is the input, your choice, and then z is columns integer num -1, and it will print the column which you have selected. Then SNS violin plot data is df z, because this is only one column z, and df is z. And if your num is more than m, so you can simply plot, you can simply write down SNS violin plot data is equal to df, then it will plot all the because we have run this portion, earlier portion, so window is already open, so it is telling me to select the file. So I will select the file as test number 3. And is asking me the choice. What is your choice? Now I say question number 6. Question number is 6. We have already noted in our file. It is a Likert scale responses 1 to 5, and let us see. Choice is 6, and your choice is question number 1. It has drawn. Now this violin, it is Q1. Q1 is the name because we have written it here. Now the density near the 3.5 is very less. Probability of 3.5 is very less. Probability of 4.5 is very less. The highest probability is near the median. This point, this white point is median. And the data above 4.5, 3 to 4.5 is thick. But probability is more highest in the near the 4. And near the 3 also is the probability high. And when it goes probability, it is very, very few, the 4.5, because we don't have 4.5, we don't have 3.5. We have got 3, 4 and 5. Probability for 5 is very less, but there are some outliers, because beyond these points, there are certain outliers. Below this 3 also, there are certain outliers, as we have seen in the box. Let us run it again. Run, and this time we are again selecting the file test4. Will ask me the choice. My choice is say 2. Age. My choice is age. Now this is your violin. Now this portion is your box plot, and this shows your probability. Highest probability is around 20. As you go on away and away, the probability goes on decreasing, and 45 probability is very less. But there are outliers. 40, beyond 40, there are many outliers, and below this around about 18, between 15 and 20, there are outliers. Now if you go for further analysis, you will have to remove these outliers. You will have to see it manually, and you will have to change it outliers. Let us see. Run again. Now I want again test 4, and I want everything now. So I will put it 7. Let us say how it goes. These are they are not visible because this income is very high. Income level is very high, thus we are not able to see the smaller violin plots. But if you enlarge the figure, you will be able to see, but we'll have to remove this income first. Let us run test 3, and I want everything. So my choice is 12, more than 11. So let us see now. It is showing all the violins here. Sector is violin is goes up to 14. All other violins are there. You can see the education. Education concentration is more between 0 and 2. Positions concentrations are between 0 and 6, but they are equally spread. Now here, question 1, you can see the violin. Question 2, you can see, and where the areas are bulging, so there is the highest probability of those numbers. Thanks for watching. In our next video, we will talk another issue. Thanks for watching. Wait for the next video. Thank you.